Hi friends, welcome to all. In this video, we are going to solve this lab activity, configure and verify extended IPv4 ACLs. Before coming to this activity, friends, if you like to get any CCNA support, you can contact our team using our website. Link you will get from the description below. And also, if you like to get this type of technical videos in future, consider subscribing. And don't forget to enable that bell icon so that you will get notification message whenever we upload a new video. Now back to this activity. Here we can see the topology. We will design this topology in Cisco Packet Tracer. Also we can see addressing table. Here we can see VLAN table. We have a VLAN 20, 30 and 40 with these names: management, operations and sales. And we have to assign these ports to its respective VLAN. We will go through the objectives. Part 1, build the network and configure basic device settings. In Part 2, configure and verify extended access control list. Here is the scenario. You have been tasked with configuring access control list on small company's network. ACLs are one of the simplest and most direct means of controlling layer 3 traffic. R1 will hosting an internet connection simulated by interface loopback 1 and sharing the default route information to R2. After initial configuration is complete, the company has some specific traffic security requirements that you are responsible for implementing. Yes, we will do that. They given a note. The routers used with the CCNA hands-on labs are Cisco 4221 with the Cisco iOS XE release. Okay, the switches used in the labs are Cisco Catalyst 2960 series. Then other routers, switches and Cisco iOS versions can be used. Depending on the model and the Cisco iOS version, the commands available and the output produced might vary from what is shown in the labs. Refer to the router interface summary table at the end of the lab for the correct interface identifiers. Yes, these instructions they give in all the labs. Ensure that the routers and the switches have been erased and have no startup configurations. If you are unsure, contact your instructor. We will go to the required resources. We need 2 routers, 2 switches, then 2 PCs, then the cables, console cable to configure the Cisco iOS device via the console ports, then Ethernet cables as shown in the topology. Coming to the instructions, build the network and configure basic device settings. Cable the network as shown in the topology. Attach the devices as shown in the topology diagram and cable as necessary. Okay, we will do that. First of all, we will design this topology in our Cisco Packet Tracer. Here we don't have this 4221 router, what they specified. So instead, we will use this 4331 router. We will add 2 routers, 2 switches, 2960 series, then 2 computers, PC. We will rename these devices as per this topology. Here we can see this is R1, here is R2, here we have S1, and this is S2. Coming to PCs, PC-A and PC-B. Now we will connect these devices. Coming to connections, choose copper straight through. Press Ctrl from the keyboard and click on this copper straight through so that we can connect multiple devices. From R1, G0/0/1 to FA0/5. From R2, G0/0/1 to S2 FA0/5. Then from S1, FA0/6 to this PC-A. From S2, FA0/18 to this PC-B. Then we will choose copper crossover to connect this S1 and S2 because they are same devices. From FA0/1 to FA0/1. We just designed the topology. Now we will configure basic settings for each router. Assign a device name to the router. we will give no, enable, configure terminal, set the host name as R1, then coming to R2, no, enable, we'll give conf t in short, hostname R2, disable DNS lookup to prevent the router from attempting to translate incorrectly entered commands as though they were host names. Coming to R1, here we will give the command no IP domain lookup. R2, no IP domain lookup. Assign class as the privileged exec encrypted password. We will enable secret class. Coming to R2, enable secret class. Assign Cisco as the console password and enable login. We will go to line console 0, password Cisco, login. Coming to R2, line console 0, password Cisco, login. Assign Cisco as the VTY password and enable login. Now we will go to exit and go to line VTY. We'll go to 0 to 4. Password Cisco, login. Then coming to R2, exit from line console and go to line VTY 0 to 4. We'll set the password as Cisco, then login command. Encrypt the plain text passwords. Service password encryption. So we have to exit from this line mode, and here we have to give service password dash encryption. Coming to R2, exit service password dash encryption. Create a banner that warns anyone accessing the device that unauthorized access is prohibited. So just I will copy this message. Coming to R1, banner MOTD, and here is the message. Coming to R2, banner MOTD, then the message. Save the running configuration to the startup configuration file. End. So here we will give this command copy run space start, enter 2 times. Then coming to R2, exit, copy run space start, press enter again. Coming to next, we will set these passwords. Assign class as the privileged exec encrypted password, then assign Cisco as the console password and enable login. Also assign Cisco as the VTY password and enable login. Finally, we will encrypt the plain text passwords. Coming to S1, enable secret class. We will go to line console 0, then set the password as Cisco, login command. Exit and go to line VTY 0 to 4, set the password as Cisco, login, exit and set service password dash encryption. We will go to S2, enable secret class, line console 0, password Cisco login, exit and go to line BTY 0 to 4, set the password as Cisco, login, exit and give service password dash encryption. Next, we will create a banner that bans anyone accessing the device that unauthorized access is prohibited. Okay, I will copy this text. Then we have to save the running configuration to the startup configuration file. Coming to S1, you will set the banner MOTD. Here is the message. Give exit, copy run space start. Then coming to S2, banner MOTD. Then the message, exit and copy run space start. Next is configure VLANs on the switches S1 and S2. Step 1, create VLANs on both switches. Create and name the required VLANs on each switch from the table above. So here we can see they given this VLAN table and we have to create these VLANs. VLAN 20 management, VLAN 30 operations, VLAN 40 sales, then VLAN 999 that is parking lot, then 1000 native. We will create these VLANs in this switch S1 as well as S2. First of all, coming to S1, configure terminal, VLAN 20, its name is management. Next is VLAN 30, name is operations. VLAN 40, its name is sales. VLAN 50, no, where there is no VLAN 50, I think, so we have to remove VLAN 50, no VLAN 50. Okay, so don't create VLAN 50 because we have VLAN 999 and its name is parking lot. Then we have VLAN 1000, its name is native. Yeah, we have only till 40, then 999 1000. Same. Next is configure the management interface and default gateway on each switch using the IP address information in the addressing table. So coming to our addressing table, here we can see S1 and S2 interface is VLAN 20. We have to set this IP address to mask and here we can see it's a default gateway. Just I will copy this IP address, S1 IP address. Okay, and here we can see it's a to mask and a default gateway 0.1. Coming to S1, conft, we will go to that virtual interface, that is VLAN 20. Press enter again because here we can see this VLAN 20 is changed, it's a state to up. We will set the IP address. I already copied it. Then we have to give it a to mask .0. Okay, then we will exit and we will set IP default gateway. It's 10.20.0.1. Next we will configure S2 with this IP address 10.20.0.3 and here we can see the to mask and the default gateway for the interface VLAN 20. configure terminal. We will go to interface VLAN 20, press enter again. Then we will set the IP address. I already copied it. Then we have to give the subnet mask. Then exit, and we will set IP default gateway. It's 0.1, 20.0.1. Yeah. Assign all unused ports on the switch to the parking lot VLAN. Configure them for static access mode and administratively deactivate them. Also, they given a note. The interface range command is helpful to accomplish this task with as few commands as necessary. Yeah, we can do that. First of all, we will do in this switch S1, and we will check what are the ports we used. So here we can see we connected to FA0/5, and here we have FA0/6, and here we have FA0/1. So except these ports, we have to assign them to a VLAN 999, and also we have to deactivate them. Coming to S1, and here we will give this command. Interface as a range, FA0/1 already we used. So we will start from 2 till 4 because 5 already we used. Then FA0/ we have to give a, let me verify. Yeah, 5 and 6 they used. Okay, that means we have to give a 7. Yeah, 7 till 24. Also, we have 2 gigabit Ethernet interfaces, G0/1-2. We will give a switch port mode access. Switch port access VLAN 999. Then shut down these ports. Okay, just give end, and we can verify it. Show VLAN brief, and we can see these unused ports we assign to VLAN 999, that is a parking lot. Also, we deactivated them. Show IP interface brief, and here we can see those interfaces are administratively down. Next, we coming to S2. Here we will give an interface as a range. FA0/2, 1 already we used, till 17 because 18 we already used. FA0/19 till 24. Also, we have a 2 gigabit Ethernet interfaces, G0/1 and 2. So we give a 1-2. Switch port mode access. Switch port access VLAN 999, that is a parking lot. Then shut down all these unused interfaces. Now in step 2, assign VLANs to the correct switch interfaces. Assign used ports to the appropriate VLAN as specified in the VLAN table above, and configure them for static access mode. And then we have to issue this show VLAN brief command and verify that the VLANs are assigned to the correct interfaces. Okay, we'll go back to our VLAN table, and here we can see we have to assign these ports to this VLAN. In S2, we can see FA0/5 we have to assign to VLAN 20. In S1, FA0/6 we have to assign to VLAN 30. Then in S2, FA0/18 to VLAN 40, and all unused ports we have to assign to VLAN 999, and this is native. In S1 we have this port FA0/6, and we have to assign to VLAN 30. So coming to S1, okay, password is Cisco, enable password is class conft. Then we will go to interface FA0/6, switch port mode access, switch port access VLAN 30. Now in S2, here we can see this port FA0/5 we have to assign to 20. Then FA0/18 we have to assign to VLAN 40. Okay, we will do that. FA0/5 which is connecting to this router R2. Exit, then go to interface FA0/5. Switch port mode access. Switch port access VLAN 5. Sorry, it's 20. Then we will go to FA0/18. This port which is connected to this PC-B, and we have to assign to VLAN 40. Exit, interface FA0/18. Switch port mode access. Switch port access VLAN 40. Okay, we can verify it. End, show VLAN brief, and here we can see FA0/5 is assigned to VLAN 20. FA0/18 is assigned to VLAN 40. Coming to S1, end, show VLAN brief, and we assigned FA0/6 to VLAN 30. Next is configure trunking. Step 1, manually configure trunk interface FA0/1. Change the switch port mode on interface FA0/1 to force trunking. Make sure to do this on both switches. Okay, we can see this S1 and S2 connected using FA0/1 both sides. We will configure trunking between this S1 and S2. Conf T, we will go to FA0/1, switch port mode trunk, and we have to go to the other side in S2 FA0/1. Interface FA0/1, switch port mode trunk. As a part of the trunk configuration, set the native VLAN to 1000 on both switches. You may see error messages temporarily while the two interfaces are configured for different native VLANs. Yeah, so once you do on both sides, that error message will be taken away. First of all, we will do it in this switch S1. We will set switch port trunk native VLAN. It's 1000. Okay. Now we will go to the other side. Coming to S2. And here we can see that message inconsistent peer VLAN ID. Okay. We will configure this side also. Switch port trunk native VLAN 1000. And now this problem restored, port consistency restored. As another part of trunk configuration, specify that VLANs 10, 20, 30 and 1000 are allowed to cross the trunk. Okay, and then issue the show interfaces trunk command to verify trunking ports, the native VLAN and allowed VLANs across the trunk. First of all, we will do it in this switch S1. So here already we are in this interface FA0/1, which is trunking. Here we will give a switch port trunk allowed VLAN 20, 30, 40, 1000. Same way we will give in S2. Already we are in FA0/1. Switch port trunk allowed VLAN 20, 30, 40, 1000. Now we will verify it. Give end, show interfaces trunk, and here we can see the details. Port FA0/1 mode is on, status trunking, native VLAN is 1000, and here we can see VLANs allowed and active in the management domain. We will verify in S1 also. End, show interfaces trunk, FA0/1 mode is on, status trunking, native VLAN is 1000. Also we can see VLANs allowed. Step 2. Manually configure S1's trunk interface FA0/5. So here we can see this FA0/5 which is connecting to this router R1. Configure S1's interface FA0/5 with the same trunk parameters as FA0/1. This is the trunk to the router, correct. Coming to this switch S1, and here we will give conf t. Then we will go to interface, that is FA0/5. Switch port mode trunk, and we will give a switch port trunk native VLAN 1000. And also here we can give a switch port trunk allowed VLAN. They are at 20, 30, 40 and 1000. Save the running configuration to the startup configuration file. Issue the show interfaces trunk command to verify trunking. Okay. Give end, copy run space start, show interfaces trunk, but here we can see only this FA0/1 which is trunking, and we cannot see FA0/5 because we have to activate this link between R1 and S1. Configure routing. Step 1. Configure inter-VLAN routing on R1. Activate interface G0/0/1 on the router R1 which is connecting to this switch S1. So we will go to that interface. Password is Cisco, enable password is class, conf t, and here we will go to that physical interface G0/0/1. Then we will activate it. Now shut down. So here we can see the link between this router R1 and this switch is up. Now we can go to this switch and we can verify the interfaces. I mean a trunk. Show interfaces trunk. And here we can see that fast Ethernet 0/5 is trunking with native VLAN 1000. Configure sub-interfaces for each VLAN as specified in the IP addressing table. All sub-interfaces use 802.1q encapsulation. Ensure the sub-interface for the native VLAN does not have an IP address assigned. Include a description for each sub-interface. Yes, now we will configure these sub-interfaces in this router R1. Coming to our addressing table, here we can see R1 sub-interfaces G0/0/1.20, 1.30, 1.40 and their IP address to mask. Also we can see this 1.1000. We have to activate and we have to give encapsulation for the sub-interface also, but no need to set the IP address here. Here we can see the IP address for this sub-interface G0/0/1.20. Just I will copy that. And here we can see it's to mask also. Coming to R1, exit and go to interface G0/0/1.20. subinterface. We will set the description also. This is management VLAN, right? So we can give this. Also we will give a encapsulation dot 1q. VLAN ID is 20. Then we will set the IP address. Already we copied it. Then to mask. Next we will configure the subinterface. We will copy its IP address. And here we can see it's to mask also. We will no need to exit directly. We can type interface G0/0/1.30. We will set a description. This is operations VLAN. Then we have to give a encapsulation dot 1q. VLAN ID is 30. Then set the IP address with the to mask. Next we will configure this subinterface 1.40. Let me copy its IP address, and here we can see it's to mask also. We will go to that subinterface G0/0/1.40. Set the description. We will give this is for sales VLAN. Encapsulation dot 1q. VLAN ID is 40. Then set the IP address with the to mask. Then we will configure this subinterface G0/0/1.1000, but no need to set any IP address. Okay, we'll go to interface G0/0/1.1000. Okay, here we have to give a description. This is a native VLAN. Don't set any IP address, but we have to give a encapsulation dot 1q. VLAN ID is 1000, and this is for native, so we have to specify native. Then we have to configure interface loopback 1 on R1 with addressing from the table above. So coming to our addressing table again, and here we can see this loopback 1. We have to set this IP address with this to mask. Okay, we will configure that. Coming to R1, exit. Then we will go to interface loopback 1. Okay, then set the IP address. Already we copied it with the to mask. Perfect. Use the show IP interface brief command to verify the subinterfaces are operational. Okay, we will use this show command in this router R1. Just give int and give show IP interfaces brief. Sorry, show IP interface brief, and here we can see the subinterfaces we configured. G0/0/1.20. Here we can see its IP address. 1.30. Here we can see its IP address. 1.40. Also we activated this native subinterface 1.1000. We can see the status. They are up. Also we can see protocol. It's up. Step 2. Configure the R2 interface G0/0/1 using the address from the table and a default route with the next hop 10.20.0.1. Okay, we will do that. Coming to our addressing table, here we can see the IP address of this interface G0/0/1 in this router R2. Just I will copy that IP address. Then also we can see it's a to mask. Okay, coming to R2. Password is Cisco, enable password is class, conft We will go to that interface, that is G0/0/1, then set the IP address, already we copied it, then give a subnet to mask, activate this interface, no shutdown, then we will exit and we will set this static default root IP root 0.0.0.0 space 0.0.0.0. Then we have to give the address they specified, the next hop address, right? So it's here, just I will copy that, 10.20.0.1. space next hop IP address. Okay, so but still here we can see this link is down. Already we given no shutdown command for this interface G0/0/1. Let us verify this interface FA0/5 in this just to Cisco enable password is class show IP interface brief. Sorry, show IP interface brief and fast Ethernet 0/5. Oh, here I given this interface administratively down. So let me bring it up. Conft interface FA0/5. We will give no shut command. So now we can see the link between this router R2 and AS2 is up. Also, I have to verify the VLANs and trunking. Let me give show VLAN brief. And here we can see FA0/5 is assigned to VLAN 20. Yeah, that's correct. Also, let me verify show interfaces trunk. FA0/1 is trunking. Yeah, that's fine. Next is configure remote access. Step 1, configure all network devices for basic SSH support. Create a local user with the username SSH admin and the encrypted password, that is a $Cisco123, then this exclamation symbol. Yeah. First of all, we will create this username and password. Coming to R1, conft username is SSH admin, then encrypted password, it's $Cisco123, then this symbol exclamation. Let me copy this command because we can give in all other network devices. Coming to S1, Cisco enable class conft, paste it and press enter. Coming to S2, conft, paste and press enter. So we are just creating username and password. Coming to R2, paste it and press enter. Use ccna-lab.com as the domain name. Okay, just I will copy that. And here we will set that IP domain name. It's here, ccna-lab.com. We will copy this command. Coming to S1, paste and press enter. Coming to S2, paste and press enter. Coming to R2, it's really easy, right? Just copy and paste. Yeah. Next is generate crypto keys using a 1024-bit modulus. Okay. Coming to R1, we'll give that here. Crypto key, generate RSA, general keys, modulus 1024. Okay, so just I will copy this line. Coming to S1, paste and press enter. Coming to S2, paste and press enter. Coming to R2, paste and press enter. Configure the first 5 VTY lines on each device to support SSH connections only and to authenticate to the local user database. Okay, we can do that. Coming to R1, here we will go to line VTY, 5 lines, that means from 0 to 4. Here we will give a transport, input only SSH, login local. Coming to S1, line VTY 0 to 4, transport input SSH, login local. Sorry, line VTY 0 to 4, transport input SSH, login local, and finally coming to R2 0 to 4, transport input SSH, login local. Step 2, enable secure authenticated web service on R1. Enable the HTTPS server on R1, IP HTTP secure server. Okay, we will give in this router R1. We will exit. In global configuration mode, we will give IP HTTP. Here we will put a question mark. And here we can see that command is not accepting here in this packet tracer. We will try IP HTTP secure server and invalid input detected. Okay. Configure R1 to authenticate users attempting to connect to the web server. Okay, we will try this also. IP, we put a question mark here, and we cannot see that HTTP command here. Okay, fine. So anyways, we are not going to do that. Next is verify connectivity. Step 1, configure PC host. Refer to the addressing table for PC host address information. Okay. Here we can see PC-A IP address. Just I will copy that. Then coming to PC-A, desktop IP configuration. Here is the IPv4 address. Subnet mask. We have to change it to this subnet mask. Then default gateway 10.30.0.1. Okay, it's here. Then coming to PC-B, desktop, change this subnet mask. Then default gateway, it's 0.1. Step 2, complete the following test. All should be successful. You may have to disable the PC firewall for pings to be successful. Anyways, we are not, using Cisco packet tracer. So we have to ping from PC-A to this destination. Coming to PC-A, command prompt, we get the replies. From PC-A to this address, default gateway. Okay. Then from PC-B, we have to ping to this address. Coming to PC-B. Okay. We have to get the replies. Perfect. From PC-B, we have to use HTTPS protocol and we have to give this IP address. But here, anyways, it's not going to work as this step we did not complete here. Next, we can see SSH. Yeah, it should work. Just I will copy this address, then go to PC-B, command prompt. Here we have to give a SSH space -L. Then username is SSH admin and the target is here. Password. Here is the password. Just I will copy that and paste here. And yeah, it's working. Next is configure and verify extended access control list. When basic connectivity is verified, the company requires the following security policies to be implemented. So here we have 4 policies. Policy 1, the sales network is not allowed to SSH to the management network, but other SSH is allowed. Policy 2, the sales network is not allowed to access IP addresses in the management network using any web protocol, that is HTTP or HTTPS. The sales network is also not allowed to access R1 interfaces using any web protocol. All other web traffic is allowed. Note, sales can access the loopback 1 interface on R1. Policy 3, the sales network is not allowed to send ICMP echo request to the operations or management networks. ICMP echo request to the other destinations are allowed. Then the last policy, policy 4, the operations network is not allowed to send ICMP echo request to the sales network. ICMP echo request to other destinations are allowed. Here, step 1, analyze the network and the security policy requirements to plan ACL implementation. Okay, before implementing this access control list, we will plan and we will write it down, all the ACLs. Then develop and apply extended access list that will meet the security policy statements. Then finally verify security policies are being enforced by the deployed access list. We will go through these policies. Here we can see the first policy. The sales network is not allowed to SSH to the management network, but other SSH is allowed. Okay, sales, that means this PC-B. Even we can verify that. Show VLAN brief. And here we can see VLAN 40 sales, port FA0/18. which is connected to this PC-B. Coming to this VLAN table, here we can see VLAN 40 sales, and also here we can see VLAN 20 is management. They clearly specified this network, that is a sales. We can see that network. VLAN 40, this network 10.40.0.1 network is not allowed to SSH to the management network. Where is management network? There is VLAN 20. This network 10.20.0.1. Okay. First, we will write down these access control entries in this notepad. So here in the global configuration mode, we have to create access list. We will create a numbered extended ACL. We will give the number 100 and we are going to deny TCP because we are going to deny SSH, and we have to give the source network address. Let me get that. Sales 40, here we can see that. Let me copy this address and we will change it to 10.40.0.0. Then we have to give its wildcard mask 0.0.0.255. Then we have to specify its destination network address, that is management VLAN 20. Here we can see its address, and here is the subnet mask 10.20.0.0, and we have to give its wildcard mask 0.0.0.255. 255. Okay, then we have to give a EQ and the port number of SSH, that is 22. Perfect. Where we will apply this ACL? We can apply to this sub interface G0/0/1.40 in the in direction. Okay. So we have to go to that interface, I mean that sub interface G0/0/1.40, and we have to give a IP access group number is 100 in the direction in. Next we will go to the second policy here. Policy 2, the sales network. Okay, again a sales network is not allowed to access IP addresses in the management network using any web protocol, HTTP or HTTPS. Okay, that means port number 80 and port number 443. Okay, the management network. The sales network is also not allowed. Okay, this sales network is also not allowed to access R1 interfaces using any web protocol. Okay, that means all the sub interfaces. Let me complete this. All other web traffic is allowed. Not sales can access the loopback 1 interface on R1. Okay, that means we have to deny these sub interfaces G0/0/1.20, 1.30 and 1.40. And we have to apply this ACL near to the source, again near to the sales. We can apply to this sub interface G0/0/1.40 in the in direction. Okay, that's perfect. So we can copy this line access list. So we will give the same number 100 and we are going to deny TCP. This is same source network with this wildcard. I think we can copy this entire line except this port number. Here we have to change the port number. So access list 100 deny TCP. This is a sales network address. It's wildcard mask. First of all, we will deny this network, management network. Okay, it's a wildcard mask. Perfect. And here we have to give HTTP port number 80. So we can give 80 or we can give www. Also we have to give for HTTPS. So just I will copy this same line and here we have to give port number 443. This is for HTTPS. Next we will deny to this destination G0/0/1.30. So here we have to change only this second octet, but I will copy these two lines. Source is again sales, and here we can see deny TCP source wildcard mask, and here in destination network we have to change to 30.0.0. This is okay. 80, and here also we have to change this destination network to 10.30.0.0. Perfect. And for the 40, again I will copy this. Really easy. And here we can see this network. Yeah, this is for sales. So this sales should not access HTTP or HTTPS even using this sub interface address, network address, that is G0/0/1.40. So here we can give that 40.0 and 40.0. This is for HTTP and this is for HTTPS. We will see the next policy. Policy 3. The sales network is not allowed to send ICMP echo request to the operations or management networks. ICMP echo request to other destinations are allowed. This policy is also again from this network sales, and we can see to the operations or management network, that means VLAN at 20 and 30. Okay, here we can see 20 and 30 management and operations. So we have to deny the ICMP from this sales network to this management as well as to this operations. and again it's from sales, and we can apply that ACL to this interface G0/0/1.40 in the indirection. Okay, here let me copy this line so that we can make some changes for this ICMP and paste here. Again we will give access list 100, deny, we are going to deny ICMP. Okay, and the same source network address, then a wildcard mask, it's correct. And here we can see this is for the management 10.20.0.0, then a wildcard mask. And here we have to give, we'll remove this port, and here we will give a echo. In the same way we have to give for this operations network, it's VLAN 30 10.30.0.0. okay, so let me copy this same line, only we have to change the destination network address from 20 to 30, so otherwise it's same. Next we will go to the fourth policy, policy 4, the operations network. Okay, here now the network is changed, the source network is changed. The operations network is not allowed to send ICMP echo request to the sales network. ICMP echo request to other destinations are allowed. Here we are going to deny the ICMP from this operations network. So this is the source network to this sales network, that is VLAN 40. And we have to apply this access control list to the subinterface G0/0/1.30 operations network in the indirection. So here let me give, I will copy this command, let me copy this line so that we can edit it. Access list, I will change the number because we have to give in another interface 101. We are going to deny ICMP from this 30 network. Okay, this is correct, wildcard mask. And here is a destination network address, we have to change it to sales network, that is 40.0.0, then wildcard mask echo, that's perfect. And they specified we must allow this echo, I mean this ICMP to other destinations. That means we have to permit IP any source to any destination. Even here also we have to give that, that is very important. Whenever we create a deny statement, implicitly they deny the entire network, I mean the entire services. So we must give this command also here. At the end we must permit, we will give access list 100. Okay, we must permit IP from any source to any destination. Okay, and here also we have to do that. Access list 101, and we must permit IP any. We have to apply this access control list in the subinterface G0/0/1.30. Here interface G0/0/1.30. IP access group number is 101, so here it's 101, so yeah, correct, in the direction in. Okay, our all policies are ready. We have to implement this access control entries in this router R1. Now it's easy. Password is Cisco, enable, class, configure terminal, and here we will do this. We will do it one by one. Just we can copy and paste this entire commands from, first of all we will give from here to here. Let me copy this and we'll check any errors will receive or not. Yeah, it's perfect. There is no errors. Just we will check it. Give end, show access list, and we can verify this access list we created. And here we can see we given here 80 and it changed to www. Yeah, it's same. Okay, that's fine. And also we can verify the direction. Show IP interface. It's a G0/0/40. The sub interface is 40. 1.40. And here we can see its direction. Inbound access list is 100. Perfect. Now we will copy this ACLs. Coming to R1, we have to go to global configuration mode, and here we can paste it. Press enter. Okay, done. Give end, copy run space start, and we will verify it. Show access list, and here we can see this extended IP access list 101. Perfect. And we apply it to this sub interface G0/0/1.30. We can verify the direction also. Show IP interface G0/0/1.30. And here we can see inbound access list is 101. Now run the following test. The expected results are shown in the table itself. Okay, we have to go to PC-A and we will ping to this destination. That means to this PC-B. Coming to PC-A, ping to that PC sales, and we can see it says a destination host unreachable. It should fail. Yeah, that's correct. Then from PC-A, we should ping to 10.20.0.1. And it should succeed. We'll check that, and here we can see we get the replies. Then from PC-B, we have to ping to 10.30.0.10 and it should fail. Let me copy this IP address. We have to go to PC-B, desktop, command prompt. Here we are going to ping to this PC, destination host unreachable. That means we ping from PC-B to PC-A. Then we will ping to this destination 10.20.0.1 and it should fail. Destination host unreachable. Then from PC-B we have to ping to this loopback. Ping to the loopback and it should succeed. Yeah, we get the replies. Now we have HTTPS and HTTPS. Okay. So anyways, now here we don't have any HTTPS service. Otherwise, we have to add a server and we can test it. Anyway, we'll do that later. So we will try now SSH. From PC-B, we have to SSH to this destination and it should fail. We go to PC-B. We have to give SSH-L. Username is SSH admin, and here is the target IP address, and we are waiting. And it should fail. Connection timed out. Remote host not responding. Yes. Now we will try to this address 172.16.1.1, the IP address of our loopback, and it should success. Just I will press up arrow from the keyboard, and here we will change this address. Yeah. Yes, it's provided for the password. Let me get the password from here. paste it here, and we can see we able to access this router R1. Now how we can test this HTTPS, right? And here we can see we have this 172.16.1.1. Actually this is our loopback address. Here we can see loopback 172.16.1.1. Okay, we will remove this loopback and we can add a server here so that we can have a HTTPS service. So let me add a server here, and we will give this IP address 172.16.1.1. Okay. Coming to R1, we will remove a loopback 1. Configure terminal, and first of all we will go to interface loopback 1, and let me give a no IP address, exit, and we will give a no interface loopback 1. Fine. So now exit, show IP interface brief, and here we cannot see that loopback interface. Now we will connect this server to this router R1. Let me choose copper crossover from G0/0/0 to this server. Now we will set IP address for that interface. Conft, go to interface G0/0/0, then set the IP address. We will set IP address from this range. Okay, let me give 1.2 because 1.1 will give for that server. Then it's up to mask. Activate this interface. Coming to this server, go to desktop IP configuration, and here we will give 1.1. Change this to mask. Then we have to give its a default gateway, that is 1.2. Okay, we will try to access its web page from this server itself using this IP address. We'll go to web browser, and here we get the web page. We'll try HTTPS also. Here I will change it to HTTPS. Okay, yeah, it's working. Now here they specified from PC-B, we have to access this protocol HTTPS using this IP address 172.16.1.1, and it should success. Okay, we will go to PC-B, coming to web browser, and we will try this. Okay, HTTP, even we can try HTTPS. Just I will close and I will reopen. HTTPS. Perfect. Click go. Yes, we are getting the web page. Next, we have one more HTTPS protocol using this address 10.20.0.1. That means management network. So let me add one more server using this network address, and we can try it. I will add one more server. We can add to any one of this switch. I will add to this switch, and we will connect it using copper straight through from G0/1 to this server. Then we will set an IP address from this subnet 10.20.0.1. So this is a default gateway. Okay, here I will give a 0.10, and we have to change this to mask. Then default gateway, and we can see this is a G0/1, and we have to change it to VLAN 20. Cisco enable password is class show VLAN brief, And here we can see 20 management. We have only FA0/5. So we will add this interface G0/1 also. Okay. Conft interface G0/1. We will activate that interface by no shutdown command. Then we will give a switch port mode access, switch port access VLAN 20. Now we will go to this server. Let me copy its IP address and we will browse from this server itself. Yeah, we can see we are able to access this web page. And even let me try from this server. Yeah, so we are able to access the web page from this server also. Here we can see we have to access that HTTPS service or that web page from this PC-B and it should fail. So that policy we set. Okay, we will try it. So here we can see 10.20.0.10 and we are waiting for the web page. We should not get the web page. It should fail. So that is the policy. Request timed out. It's not going to work. Even we can try HTTPS. Here I will give a HTTPS, then go, and it should fail. Perfect. Our policies are working. This is the policy, right? This sales network is not allowed to access this management network, even this sales network. Okay. So let us try from this PC-A. We will try to access this server. We can see it's working. Even HTTPS also will work, no doubt. Yeah, perfect. So friends, in this video we configured this lab activity. Configure and verify extended IPv4 ACLs. Now, dear friends, if you have any doubt, any suggestions regarding this lab activity, please comment below, or even you can contact our team using our website. Link you will get from the description below. And now, friends, if you like our video, give a thumb and share with all your friends. And if you don't like, please give the suggestions for improvement. Stay tuned. We will meet again with the next video. Thank you.